So, suppose we're going to play rock, paper, scissors against the machine. How do we program the machine to play? Well, we need to somehow tell the machine what strategy it should use. And what that means is what should be the next move it makes. And I guess the decision, it takes that decision on the basis of what you have played so far. So we can say a strategy is a function from a list of moves, that is the moves I have made so far, to the choice the machine makes on the basis of that. And if you think that's what your strategy would be like, you decide what to play next, informed by how you see the machine has played so far. So a strategy is a function from a list of moves to the next move to be played. Here are three simple strategies. One is rock, the next is paper, the third is scissors. And these are functions that always return the same answer. Rock, it says \moves arrow rock. The way we read that is the function that takes a list of moves to rock. So the lambda says the function, then it's followed by the argument, the parameter, and then after the arrow, the results. It's called a lambda expression after the Greek letter lambda, and it's a way of writing down a function as an expression. And I think, as I said right in the first segment of this whole course, lambdas coming from functional programming languages are now in all modern programming languages. That's how you write the function that behaves in a particular way. So we can write constant strategies, but that's not a very interesting strategy to play. One thing that we can do, and this is not a bad strategy, is that the machine can reply with my previous move. So you reply with the player's last move. So you think, okay, they played that last time, I'm going to play it this time. And that's a strategy called echo. And if you look what echo does, it takes the list of moves and it takes the head. So I'm assuming here with the list of moves that the most recent move is at the head of the list. So that works fine, except it doesn't tell us what to do when the list of moves is empty. It doesn't give us an initial move, because the strategy applied to an empty list gives us the first move of that player. So what do we have to do? We have to change it in order to pass in the first move. So what we now have is echo is a function. It takes the first move to play, here start, and it returns this function. Lambda moves. If that list is null, the answer is start. Otherwise, it's the head of moves. So that's the echo strategy with a start move as well. Now, I think my favourite strategy is to bet on the player not making the same move twice. Now, suppose we guess, if the player played scissors last time, suppose we guess that he or she doesn't play scissors again. That means he or she will either play rock or paper. The right thing if we guess that, then the right thing for us to play is paper, because either paper will draw with paper or paper will win against rock. So what we do here is we play the thing that would lose against scissors. So this is the strategy lose last. And it's betting on the player not playing the same thing twice. So what we say is, given the list of moves, what do? We take the head of it, the last move, and apply the function lose to it, which remember is tells us the thing that will lose against that particular move. Now again, that doesn't work if the list of moves is empty, so we again have to pass in a start move, and so this lose last strategy applied to start gives us a strategy which is lambda moves. If that list is null, then we return start, otherwise we apply lose to the head of moves, that is the last thing played by the opponent. And that's betting on the fact that he or she won't repeat a play. And that's actually a good strategy. Empirically, that's a good strategy. People, when they think they're playing randomly, actually repeat themselves less than truly random behavior. The other thing we could think of doing is to try and beat what we think is a strategy behind the opponent's choices, and that's the function given here. And finally, there is a random strategy that just chooses values at random. That's implemented using some rather murkier stuff inside Haskell, just to give us a random function. But let's not worry about that too much. But it's certainly a perfectly viable strategy. Now we've got strategies, we can think about building an interactive game-playing machine. But before we do that, just let me emphasize that what we've introduced here is one of the key ideas of functional programming. That is the idea of functions as data. Each strategy here is a function, and we've seen that we can have strategies as a result of functions. We can also pass them in as arguments to functions. So it means that we can have functions that depend on behavior, that is, functions as data. And this is really one of the essential innovations of functional programming. And you see, we've seen that already with things like map and filter, where we pass in the function f we pass in to map is itself is behavior, is functionality. But what we've seen also here is that we can return functions as results of other functions in quite a natural way.